Chapter 1, Video 4 lecture. Today we're going to talk about the cardiac cycle. When we think about the cardiac cycle, we're thinking about systole and diastole, and that's two of the phases of the cardiac cycle. And in order to better understand this, I want to go over with how the heart beats first, because I think it will help you. You have the two atrium on the top of the heart. You have your right and left atrium at the top of the heart, and then you have your ventricles, your right and left ventricles at the bottom of the heart. So what happens is the atrium squeezes and it pushes blood out into the ventricles. As the atrium relaxes, the ventricles squeeze while they're relaxing, and they push the blood out to the rest of the body. And then it works like that simultaneously. So your atrium will contract and then your ventricles. Atrium and contract. And atrium and then ventricles. Atrium and then ventricles. So your atria contract, then your ventricles contract. So what's happening is while your ventricles are relaxing, your atriums are contracting and pushing that blood down into the ventricles. As your ventricles contract, the atrium is filling, and then as they relax, it'll squeeze and push that blood down into the ventricles, just so you kind of understand that. But when we talk about diastole, the very first phase of diastole is the rapid filling phase. So during this phase, the atria has greater pressure. It's just received all this blood from the superior and inferior vena cava, and the ventricles have a lower pressure because they're actually sending the blood out to the lungs and to the body. So the difference in the pressure allows the AV valves to pop open and the atrial blood to flow down into the ventricles. An example of this, we need to think about two balloons with the top balloon full of water and the bottom balloon having an increased pressure. So this top balloon's full of water, the bottom one's empty. So the top one has a greater pressure, and that greater pressure makes that valve pop open, and then that water is able to flow down. So think of that as an example with diastole. Now we're going to talk about diastasis. Diastasis is the second phase. The pressure actually starts to equalize as the atria empty into the ventricles. So the blood flow slows during diastasis. So during diastasis, it is the very second phase, and then the atria is starting to empty, and then everything's equalizing out as the blood flow flows down. And then the third phase is the atrial kick. This is the very last phase of diastole. So we have two phases. We have diastole and systole. Diastole is a three-part phase: rapid filling phase, diastasis, and then the atrial kick. During the atrial kick, the atria is almost empty, but it still has a very little bit of blood left in there. So it has to give a small extra contraction to get this last little bit of blood out of the atria and into the ventricles. And so it happens at the end of the phase. So you got your heartbeat, you got your atrium when it contracts and squeezes, and then at the end of that cycle, you get just another little nudge, and it makes those atria empty on out and gets everything extra out and pushes it into that ventricle. Now we're going to talk about systole. The two phases of the cardiac cycle are diastole and systole. So now we're going to talk about systole. When we talk about systole, systole has four parts. There's four components to systole. The very first one is the isovolumetric contraction. Okay, during this time, it is the very first phase of systole. So all the valves are closed. The ventricles are full, but the pressure in them is not yet high enough to make those valves pop open. Okay, so it's we're kind of at that equalizing stage, but we're going past that now. We're going into the systole, and we're going into isovolumetric contraction, which is what we're talking about. But that pressure's not quite high enough to make those valves pop open. During ventricular ejection, this is the second phase of systole, the ventricular pressure is high enough that the semolina valves pop open and blood pours out of the ventricle into the pulmonary and into the aortic artery, okay? So ventricular ejection, we just got enough pressure that this valve's going to open, and it opens and blood starts rolling out. During prediastole, this is the third phase of systole, ventricular contraction continues, but the blood flow slows as the ventricular pressure drops. Aortic and pulmonary artery pressure rise because they are filling with blood, and then the pressures begin to equalize between the ventricles and the aorta and the pulmonary artery. And then fourth, we have the isovolumetric relaxation. This is the final phase of systole. It's the very last thing that happens. The ventricular pressure is low because blood has been pumped out. We want to relax pressure, and we relax and the pressure drops further. The aortic and the pulmonary artery have higher pressures now because of the moving of the blood. But there's no longer any forward pressure from the ventricles to continue to push its blood, so it starts to travel backwards down those arteries, and as it starts to travel backwards down the arteries, the blood that's traveling backwards actually pushes those valves shut. So, and then we've talked about the blood flow of the heart. We need to, at this time, talk about the blood flow through the systemic circulation. So we've talked about from the inferior and superior vena cava all the way to the systemic circulation. It's gone through the aortic valve, out of the aorta, and into the body. Well, what happens, what we're talking about with systemic circulation is what happens to the blood after it leaves the aorta. Where does it go throughout the body? So this is where we're talking where it goes and what happens outside of the heart. So it leaves the aorta, it goes into the arteries, then it travels to the arterioles, then to the capillary beds, and the capillary beds is the step here which exchange occurs. So at the capillary beds, it picks up all of this cruddy, nasty CO2, and it gives off the oxygen. So we've left the aorta, we're oxygen rich, and we're taking this oxygen to the rest of the body because it now needs it. So when we get to the level of the capillary bed, this is where we give the oxygen away to all the organs and all the tissues, and then we pick up the waste, the CO2. And then by the venules and veins, it travels back to the vena cava to start to cycle over. So the systemic circulation lies between once it leaves the aorta and gets back to the superior inferior vena cava. That should make sense to you. And this is the order in which it happens. And then again at the capillary bed, that is where the exchange actually happens. And now I want to scroll down and talk to you guys about coronary arteries. When we think about the heart, we think about all of these big chambers in the heart pushing the blood out. We have this big muscle, and it's squeezing, and it's pushing the blood out. Well, guess what? The heart has its own blood supply as well. It has to receive nutrients in order for it to work. So the coronary arteries actually arise from the base of the aorta, and they course along the epicardial surface, but then they dive down into the myocardium to provide blood supply. So they kind of dive down into those muscles to get blood supply. The myocardium receives its blood supply during diastole, and it receives it during diastole because at this point in time, that's when the heart is resting and filling. So it can't receive its blood supply when the heart is contracting. It gets its blood supply when the heart is actually in the resting phase. So this is also called the coronary circulation. So the myocardium extracts the nutrients and the oxygens from the coronary arteries, and then the deoxygenated blood is then returned to the right atrium by the coronary sinus. So just think, the coronary arteries are the arteries themselves that supply the heart muscle with oxygen and nutrients. And I'm going to stop this lecture here, and we'll pick up with the coronary arteries when we come back.